see if I can add this back. Now, I'm not really going to add, but what I'll do is I'll multiply. So here's what's going to happen. I'm going to take my r, I'm going to multiply it with Sn. When I multiply by with Sn, watch what happens, okay? I'm going to take every single one of these terms, I'm going to multiply it by r. So I take this T1, I'm going to multiply by r, and it's going to look like this. I'll have a T1r. Okay? I'm going to take this term, T1r, I'm going to multiply it by r again. It'll be T1r squared. Okay? And so forth and so on. I'm going to take this T1r squared, I'll multiply by r. I'm going to get T1r cubed. And I'm going to put plus signs in between these guys, okay? And then this one over here, I'll have another previous term that's multiplied. I have T1r n minus 2. I'll take this T1r n minus 2. I'm going to multiply by r. I'm going to add it to T1r n minus 1. So take a look right here. I've got all this, and at the same time, if I were to take this and this last term that was on top and add it to here, multiply by r and add it to my bottom series, it's going to be T1r n. Okay. So if you wonder how I got this red row, I'll tell you. I took every single one of these terms in the black and I multiplied it by r. So this is multiplied by r, 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 multiplied by r, multiplied by r. That's how I got my new terms. T1 times r is T1r. T1r times r is T1r squared. T1r squared times r is T1r cubed. And so forth and so on. I just want to make sure that the term appeared under here, so I would have taken T1r n minus 3 multiplied by r, that would have added an extra exponent, it would have ended up there, and so forth and so on. I now have a red series. What do you want to do, okay, here? And unfortunately, I must have probably said something wrong here. I must have been thinking something else. I didn't mean add backwards, okay? I meant subtract. Okay, that's what I meant over here. So maybe we should change that. Okay, Cito makes mistakes too. That's the mistake I made today. And what's going to happen is that, what can I do? Like, let's think about this for a minute. You guys are pros now at this, in my opinion. How do I get rid of all these terms in the black and most of these terms in the red? What do I do? How do I do it? Think about it for a minute. Well, have you thought of it? If I were to get rid of all these terms, it would look something like this. I would have to subtract. Because watch what happens when I subtract the bottom row from the top row. Well, first of all, this bottom part is going to end up being Sn minus Rsn. Okay? And it's going to equal, okay, T1 minus 0 is just T1. But you see what happens to these guys? T1r minus T1r, they are just gone. T1r2 and T1r2, when you guys subtract these guys, they're also just gone. Okay? And so forth and so on. This is gone. T1r n minus 2, if it's subtracted from T1r n minus 2, that's gone. T1r n minus 1 subtracted from this one is also gone. And this subtracted from here, there's going to be a minus sign for this T1r n. It's going to be minus T1r to the n. Okay? So what I'm going to do is I'm going to combine all this entire sentence. There's a huge gap here. And if you wanted to know what this gap was really, if you subtract this stuff, you really ended up having plus 0, plus 0, plus 0, plus 0, plus 0. And it was just basically a giant row of zeros, which we can ignore promptly. So the left side is going to look like this. I'll have a Sn minus Rsn is going to equal my T1. I'm going to subtract it to T1 Rn. You see what I did? I basically just discounted all these zeros, got rid of all of them, and I end up with a minus T1 Rn. And if you wonder where that minus sign came from, remember, if there's a 0 here, 0 subtracting a T1 Rn gave me this minus sign, just to let you know. All right, let's move on. So I have that down, and you're thinking, man, you suck. I hate you. I hate math now. How do I do this? I have 2 Sns. Well, never fear, okay? Just think back to your Algebra 1 days. If you saw 2 with the same thing, factor it out, and you end up with the following, T1 minus T1 Rn. Okay, so far so good. Oh, I know my next step, and I know you can see it too. All right, I can probably factor this too and be a good math student. I can factor T1 out, and it's going to end up like this, 1 minus r to the n. Okay, and the left side, Sn 1 minus r. Watch this. Can I solve for Sn? And I think, yeah, and the answer is yes. And you know what's coming up next. I'm going to be dividing by this term 1 minus r. So my formula then is the following. I'll write it here in blue. My formula for my geometric series is going to be T1 times 1 minus r to n. That's this upper part right here. I'm going to divide it by 1 minus r. Okay? This is my formula, where T1 is my first term. Okay? R is my common ratio. Your exponent n is the number of terms. Okay? And then that's it. And S, of course, is your sum. Now, that being said, is this for an infinite or a finite geometric series? I'm not going to answer that because I want you guys to think about this. Okay? Given everything I've got right here, is this possible with an infinite series? All right. Well, while you're thinking about that, I'm going to show you what it is for an infinite. Okay? So this was for a finite. We'll move on to an infinite one. Okay? So we'll call this geometric finite. All right? So that's the answer to that one. A finite geometric series, that's the formula for it, and that's the proof. So again, one more time, I'm praising you if you understood even 50% of what I did right here and why. Understanding the why things happen in proofs is super important. That's going to get you through math and higher level math. All right, let's move on. Good for you. Let's do the last proof we've got right now, and it's going to be my infinite geometric series. Okay, infinite geometric series formula. But to do this proof, I'm going to show you a couple series, okay? And you tell me if it's humanly possible to find its sum, okay? So here's my first geometric series I want to show you. It's going to be this, okay? I'm going to be taking 1, adding 2, 8, 16, dot, 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 dot. And it just keeps going and going and going. Can I find this sum? Can I? Be real with me. Is it possible? Because truth be told, it's going to keep going. Yes, you know your R, okay? You know your R. Here your R is 2, right? And here your R again is 2, and so forth and so on. You're thinking, hey, I know my R. I could do anything. All right? Well, the truth of the matter is, yeah, you keep adding it, but you're going to end up with a total. That total is going to be infinity. It's not going to work out. Okay? If you go back to the formula that we just learned right now, the one you just learned, okay, let's go back to our geometric series. If we used it as, especially with a finite one, this is a 1, by the way. It's number 1. Okay, which one of these terms is going to expand to something massive? Well, let's think about it for a minute. I'll put it in. Okay, T1 is basically the number 1. So let me write that as number 1. I'm going to have 1 minus r. R is 2 because we've figured that out. And n, we don't know what it is. So let's call it n to the infinity. All right? And so forth and so on. And then we have 1 minus 2. Which one of these terms is going to be huge? Well, it's going to be this one. This is actually going to be huge. All right? Not going to work out for us mathematically, mathematics-wise. If you were to simplify this, it'll look something like this. It's going to be basically negative 2 to the infinity over negative 1, or it'll be 2 to the infinity, which you know 2 to the power of a humongous number is going to be infinity in itself. All right? This is what we call a divergent series. Divergent series occurs when r is greater than 1. And this series is geometric. Your results cannot be calculated. Okay? This is still not going to work. All right? Your r is greater than 1. It made this exponent here super big, and it made this power, the resulting power, super huge. Your base is greater than 1 right here. This is your r. Remember, this is r. R equals 2. If you were to take that and put it as an infinity over here, it's going to be massive. So no way. That didn't work out at all. Let me give you another series. So just watch this. So this series, didn't work out for us at all. Let me give you another one that might work out. Okay, let's try this one. Tell me right now if finding this one is going to be easier. Why? Why would this be simpler to calculate than the previous one? Can you tell me why that is? Well, truth be told, if I were to look at my r's again, my r in this case is what? 0.1. And if I were to multiply my second term by 0.1 again, wouldn't I get something to the hundredth place? Hundredths place is 0.01. If I were to multiply that by r again, I get something to the thousandths place. This is 1, by the way, right here. Do you see what I'm saying? So, honest to God, my r is less than 1. Is less than 1 this time. I might be able to pull this off. Okay. So, bottom line is this. Let's go back to our trusty formula. It's going to be T1 times 1 minus r to the n. Okay. And it's going to be 1 minus r over here. If I were to sub in all my values, let's do it one more time. It's going to be 1 here, 1 minus, my r is going to be 1 over 10, okay, because I like fractions. I'm going to say that my r here is going to be 1 over 10. See how I got that? Because it had a decimal here. I turned it into a fraction, right? I'm going to take this r, I'm going to turn it into that, and I have 1 to the r minus n, okay, and 1 minus 1/10. If I were to simplify this, and I know you know how to do it. If you want to pause the video and do it yourself, that's fine. But you're going to see the following, okay? Is that I'm going to have 1 minus 1 over 10 n, and this is going to be 9 over 10. Okay? It's as simple as I care to make it at this point. Which one of these terms is going to vaporize and disappear? Can you see it? One of these numbers is going to go and go bye-bye. And I'll tell you which one. It's this one. I'll show you why. Because as n gets really large, we'll say as n approaches infinity, okay, 10 to the n also approaches infinity. Don't you think? Of course it will. Anything to the nth power, if it's greater than 1, totally is going to work. But here's the thing. It's a fraction. 1 over 10 to the n, however, is going to approach 1 over infinity, if you think about it. Because this 10 to the n down here is going to become infinity. So I'll slow down one more time. This 10 to the n is going to be infinity, because as n gets super large, you're going to end up with something like this. Okay? So, but take a look. 1 over infinity, I take 1, I divide it infinite number of times, is really going to approximate the number 0. Okay? So whatever this is right here is going to really approximate the number 0. And what I'm going to have left is the following. It's going to be Sn equals 1 minus, okay, 1 over infinity, 9 over 10, or it's going to be 1 minus 0, 9 over 10, or 1 over 9 over 10. Do you think I'll be able to solve for this series? Well, this one I can. Okay, it's going to be basically Sn equals 10 over 9. This is my answer, okay, or 1.1111. All right. If you think about why that's true, let's go ahead and make sense. I'm not really dwelling on the numbers here, but the one thing I want to do is label this series. This series is what we call convergent. Okay, it's a series when your common ratio r, okay, is greater than 0 and less than 1. Okay, on the positive side anyways. Next year we're going to look at the negative side. But bottom line, r is going to be like this. Okay, we will be able to calculate a value. We will be able to find a value. Okay, so these are the proofs that I just wanted to show you right now. If I wanted to then find a formula for this, the formula then would be the following. If you could base it off of what we just did. In my previous formula, I had T1, 1 minus r to the n, right? Okay, and 1 minus r. If I knew that this was going to disappear, disappears because the series is convergent, I can rewrite this formula, can't I? I could write it as the following. It's going to be the following. It's going to be T1, 1 minus r. Done. Because I know if I cross this off, this one here becomes meaningless, and I just have a T1 that's left over the numerator side. I end up with this formula right now. So what is this here? This then basically is my series for my infinite convergent geometric series. Okay, and you really have to look at the